Hi you guys, today we're going to be practicing multiplying a fraction by another fraction. So to jump on in, we're going to start by looking at a real world situation to give us a kind of sense of when would we be using this skill of multiplying a fraction by a fraction within our real world experience. So let's say we're having a friend over after school. When on the hunt for an after school snack, you discover that you have 2/3 of the pizza your family ordered for dinner last night in the fridge. You want to share half of this pizza with your friend so your family still has leftovers for dinner. What fraction of the whole pizza would you be sharing? So in this situation, we have a fractional part that we're looking at. Let me just switch this to white. There we go. So we have a fractional part that we're looking at of the pizza. We don't have the whole pizza. We have 2/3 of the pizza. And we don't want that whole 2/3. We only want half of that. So what we want is 1/2 of those 2/3. Now, in math up to this point, we've talked about how the word of is going to translate to multiplication. That word makes our brain think multiplication. So what we're really doing here is when we're taking half of 2/3, we're multiplying 1/2 times 2/3. And we've also talked about up to this point how multiplication can work either way. So this could be 1/2 times 2/3, 2/3 times 1/2. They can be reciprocated and they're going to give us the same answer either way. So let's take a look at how we're going to solve this using an area model, a tool we've used in other scenarios throughout the year. We're going to apply it to this too because it's a really simple way to break down what this is going to look like in a visual that will make sense for us. So we're going to start by drawing the pizza that we do have in our box, which is 2/3. I'm going to make this a rectangle pizza just to make our lives a little bit easier when we're visualizing this. Could you do it with a circle? You could. It's going to be a little bit harder to draw, so we're going to keep it simple and keep it a rectangle. Now, we have 2/3 of a pizza, so I'm going to take this rectangle pizza and I'm going to split it into thirds, and I want 2 of them. So this is representing my 2/3 of the pizza that we have left over from dinner. Now, I don't want all of that pizza. I only want half of this 2/3. So what I'm going to do is take this 2/3 and I'm going to split it in half. I'm going to shade this in opposite color to really show that difference between the two parts. So now I've taken 1/2 of the 2/3 that I had left over in pizza. Now, if I want to find out what is a half of those 2/3, what I need to do is look in my area model for the part that is double shaded, where these paths have crisscrossed, where I've taken that half of the 2/3 that I had. And if we look here, we can see we have 2 pieces. So we have 2 pieces out of the 1, 2, 3, 4, 5, 6 that we've had in total. Now, we know from looking at fractions in the past that 2/6 is going to simplify to 1/3. If I divide each of those numbers, my numerator and denominator, by 2, that's going to simplify to 1/3. So what this is telling me is that 1/2 of, or multiplying 1/2 times 2/3, is going to give us 1/3. So we have 1/3 of that pizza that we can eat, so make sure that our family still has leftovers for dinner tonight. Okay, so let's take a look at another one. We're going to practice using this area model without a word problem this time, just keeping it straight numbers. We're going to practice this together, so have something out in front of you that you can practice along with me, whether that's a little whiteboard, piece of paper. Doesn't matter as long as you have something out to try with me. We're going to draw this out again. So this time we are looking at 3/4 times 2/3. So to start, we're going to draw out our area model. We have our rectangle. It's the easiest to keep us nice and organized and really visualize what this looks like. We want to start with our first number here, so we have 3/4. To do that, I'm going to split my rectangle into fourths. And my numerator tells me I need 3 of those fourths, so I'm going to shade in 3. Doesn't need to be perfect, as long as you can determine what three parts you have colored in, and they're colored all the way down so you don't get confused when you get to the next step. Now, we want to take 2/3 of those 3/4. So in the opposite direction, I'm going to split those 3/4 into thirds, and then my numerator tells me that I want 2 of those thirds. So I'm going to shade them a different color so I can visualize myself taking 2/3 of those 3/4. Now, like we talked about before in our last example, where we're going to get our answer for this is looking at the part of our area model that is double shaded, where these fractions have crisscrossed, which is all of this section right here. So if I take a look at this, I see my numerator is going to be how many pieces I have double shaded. So I see 1, 2, 3, 4, 5, 6 pieces. And my denominator is going to be how many pieces I have in total in my whole. So if I look at that, I know I have 6 that are double shaded, plus 7, 8, 9, 10, 11, 12 in total. So I have 6/12. I also recognize from simplifying fractions in the past that 6/12 is the same thing as 1/2. So what this is telling me is that 3/4 times 2/3 is the same thing as 1/2. Okay, now it's going to be your turn to try one. We're going to go over it together after you've had a second, but I want you to pause this video, take the chance to try out this problem right here, and then we'll meet back together in a second. I'll give you a second to pause before I start talking. Okay, so by now you should have had the chance to attempt the problem. You paused it, you tried it. Let's go over what it would look like before we move on with the lesson. So we have 3/5 times 1/4. Again, I'm going to start with my area model. This time I'm going to break it down into fifths. These are a little bit trickier to draw. Mine are not perfect. Ideally they would be, but just to get through the sake of the video, let's move on. I have 3 of them. And then I want to take 1/4 of those 3/5. So I'm going to split them into fourths and color in one of them. All right, now I want to take a look at my double shaded pieces. That's going to give me my numerator. So I see I have 1, 2, 3 pieces double shaded. And we need our denominator to be made up of how many pieces we have in total. So if I know I have 3, I now have 4, 5, 6, 7, 8, 9, 10. Ooh, my goodness, that was not good counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, just off with a dot. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Another way to make our lives easier than counting one by one, we can see that this is a 4 by 5 grid. We know that 4 times 5 is 20. Now, 3/20 cannot be simplified. There's not a number that I can divide the numerator and denominator by that's going to simplify this fraction. So we know our answer is going to be left as 3/20. Hopefully you got that. If not, you can always pause the video, retry it, and see if you get it a second time. Now, to progress on, let's talk about what we notice. If we go back to the equations with their answers that we've taken a look at, we should notice that there is a pattern that's going to help make our lives quite a bit easier when we are trying to progress from that area model onto a more simplified way of solving. So if we take a look at the problems that we've done so far, let me just write those out for you. Go back to white so it's easy to see. So we have done 3/4 times 2/3 equals 6/12, which we said was the same thing as 1/2. And we've also done 3/5 times 1/4 equals 3/20. Okay. Now, if we take a look at the numerators and the denominators across the board of what we've been getting as an answer to our equation, you should notice, and I'm going to color code this the best I can for you. If we take a look at the first one, our numerators are 3 and 2. our numerator in our answer is 6. If we're multiplying 3/4 times 2/3, that means our numerators are getting multiplied, 3 and 2, which does equal 6. So we can see a pattern here where 3 times 2 equals 6. Our simplified version is not going to help us out in noticing this pattern, but I did want to leave it there just so you guys make that connection. If I take a look at our denominators, I have 4 and 3. If I multiply 4 times 3, I get 12. So again, that pattern is repeating. If we take a look at our other problem, 3 times 1, my numerators, is going to give me 3, of course. So the pattern continues. And with my denominators, I have 5 times 4, which is going to give me 20. So the beautiful thing about multiplying fractions by fractions is we have a really simple shortcut or algorithm that's going to help us solve these problems more efficiently when we don't want to be solving with the area model. When we start getting to bigger fractions with larger numerators and larger denominators, it's going to take you a really long time to solve with an area model, and it's not the most efficient method of solving. This algorithm that I'm going to teach you right now is going to make this more efficient and a little bit easier when those numbers get bigger. So let's take a look at a new problem. We have 5/6 times 3/4, and we're going to try this using the algorithm to switch things up a little bit and make our lives more efficient. So if I have 5/6 times 3/4, from our pattern that we just looked at, we know that if we multiply our numerator times our numerator in our question, it's going to give us our numerator for our answer. So I know that, let me color code this, 5 times 3 is 15. So I'm going to take that as my numerator. And I know that 6 times 4, my denominators, are going to give me 24. I'm going to color code that one too. There we go. Okay, so easy as that. 5/6 times 3/4 is going to give me 15/24 because I know my numerators, 5 times 3 equals 15. My denominator, 6 times 4 equals 24. With this, I can simplify this. The number that comes to mind for me right away is 3. 3 is going to go into both 15 and 24. So if I'm going to simplify that 15 divided by 3, I would get 5. If I take that 24 divided by 3, I'm going to get 8. And this is as simple as I can make it because there isn't a number that's going into both my numerator and denominator, 5 and 8, that would simplify this any further. So 5/6 times 3/4 is going to give me 5/8. See how much faster that was at solving? A lot more efficient. Let's try it again. All right, so now, sorry about the fractions looking funky on the slide. I don't know what happened there, but let's take a look at 2/7 times 3/5. All right, so we know we want to take a look at our numerators first. So let's color code those, and our denominators second, and then we'll simplify if we need to. So we know that 2 times 3, our numerators, are going to give us 6. Our denominator, 7 times 5, is going to give us 35. Super quick, super simple. If I'm going to simplify this, the number that comes to mind, I don't think there is one. For 6, my factors are going to be 1, 2, 3, and 6. 1's not going to help us simplify 35. 2 is not going to help us. I don't think 35 is divisible by 3. Yeah, no. And 6 is not going to help us either. So yeah, 6/35 is how it's going to stay. So this one just ended up with no simplified version, and that's okay. This algorithm helps us solve quickly and efficiently. All right, so now let's try this again. You're going to pause this video right now. I'll give you a second once I stop talking to pause. We're going to go over them after you've had the time you need to solve, and try to do this using the algorithm instead of using the area model. You can go ahead and pause right now. All right, so we're back. Let's go over these with the algorithm. For our first one, we had 6/7 times 8/9. So let's write that out, and we can see why, even with just this problem alone, why this method of solving makes her life a lot easier, because can you imagine drawing sevenths and ninths? It's going to be tricky to get those as accurate as possible and as even as possible with an area model. So if we multiply our numerators across, 6 times 8 is going to give us 48. 7 times 9 is going to give us 63. Now we can simplify this out. Our numerator and our denominator are both divisible by 3. If I take 48 and divide that by 3, I'm going to get 16. And 63 divided by 3 is going to give me 21. So 16/21 is going to be our simplified version of the first problem. For the second one, we have 2/5 times 3/8. Multiplying my numerators across, 2 times 3 is going to give me 6. 5 times 8 with my denominators is going to give me 40. If I simplify this, I know that both of these are divisible by 2, so I'm going to take that and make it 3/20. I can't simplify that even further, so that's going to be my answer with 3/20. All right. If you need to review any step of this, go back and rewatch this video however much you need to. Pause it, try the practice problems again. You can always make up your own problems by taking your own fractions, mixing up some numerators, denominators, trying it out with the area model versus the algorithm, and I will see you in class tomorrow.